Hi, my name is Bill Lindsay. I'm Field Systems Architect for Wireless Sensor Network Products at Linear Technology. I'm going to talk about the SmartMesh IP network products and specifically focus on the wide range of sensor applications that these network products can address with very straightforward network configuration choices. There are simple interfaces that allow your application to communicate how the network should behave. From that point, the network takes care of network management so you can focus on your application. In this video, we will examine how to use these interfaces to tailor network performance to meet your system requirements. In all these examples, the primary trade-off is speed versus power consumption. A SmartMesh IP network is comprised of a SmartMesh IP manager and a number of SmartMesh IP motes. Each mote represents a place where your sensor application can send data across the network. The manager is the device that builds and maintains the network and also represents the place where sensor data is delivered and made available to your data collection application. Any one network can consist of up to 100 motes, such as the LTC 5800 IPM, and one network manager, such as the LTC 5800 IPR. In my setup, I will use a PC to communicate with a SmartMesh IP manager or a mote using software tools I downloaded from linear.com. For the examples in this video, we will consider the configuration choices for a 20-mote network that is 2 hops deep. By this, I mean that some of the motes can communicate directly to the manager over the air, and other motes must route their data through other motes. The factory default configuration of the network is an excellent choice for most monitoring applications. It assumes that all devices are powered similarly, for example, when all devices are battery powered. This is a good setup for sensor applications that will publish data in the range of once per minute to once per second. In this configuration, there are network resources available for moderate downstream communication from the host application down to individual sensors. When an individual mote is powered up, it joins the network. Part of that process involves the mote telling the manager exactly what the sensor application is going to do. This exchange is called a service request. In response to the service request, the manager lays in the necessary network bandwidth and tells the mote when that bandwidth is available. Using the temp monitor application in the SDK, I can see that all 20 of my motes are configured to send data once every 30 seconds. I can modify the service level by changing this value. I will set 5 of the motes to report every 10 seconds, and set 5 motes to report every 5 seconds, and set another 5 motes to report once per second. For all these changes, the network manager will lay in just the right network resources for the expected traffic. Every mote will receive enough resources to yield ultra-high data reliability, but not too much to waste energy and reduce battery life. The service request interface at the mote allows the network to flexibly support a wide range of sensor applications. Now let's look at how we evaluate power consumption. The vast majority of end users of wireless sensor networks care very much about battery life, and battery life is expected to be measured in years. You should evaluate power consumption in 3 steps. We provide a tool called the SmartMesh Power and Performance Estimator to help predict the power consumption of motes in the network. Then, on the board provided with the evaluation kit, you can physically measure the power consumption of a mote and compare it to the prediction. Finally, you can compare the network health reports that are published by the motes and check those for accuracy. At the end of this 3-step approach, you will have confidence that the mote health reports are accurate, so you won't ever have to do your own measurements. And you will have a good idea how the Power and Performance Estimator enables you to estimate power consumption. The Power and Performance Estimator is an Excel spreadsheet that takes inputs from you and calculates the power consumption of your motes. Your inputs include network topology, data rates and packet size, supply voltage, and the packet success rate in the network. The outputs you receive include average current consumption, data latency, and network formation time. Some of these you might not know ahead of time, but that is one of the major values of this tool. It helps to illustrate what parameters are more important and which are less important. Please check the application notes on linear.com for details on how to use this tool to do a sensitivity study about networks. Using the Power and Performance Estimator, I can see the cost in battery life of sending data at faster rates. As you would expect, when I set the data rate faster, I can see that motes will consume more energy. When I set the data rate slower, the same motes use less energy. The main point here is that it is the same network that always works at ultra-high data reliability. We already have a great deal of flexibility to drive the network to higher speed or to lower power. If your sensor application reports data slowly, and if you rarely need to send commands downstream from the host to the motes, there are two ways to significantly decrease power consumption and increase battery life. These two approaches are turning off network advertising and reducing downstream communication. In my 20-mote network with the standard network configuration, the power and performance estimator tells me that my 1-hop motes will be consuming about 49 microamps, and the 2-hop motes will be consuming about 32 microamps. If I turn off network advertising, the power consumption drops almost in half. The second thing I can do is turn down the speed of downstream communication. When I change the downstream frame size from 256 to 1024, power consumption drops again. With these two changes, my 1-hop motes dropped to about 25 microamps, and my 2-hop motes dropped to under 10 microamps, and the sensor data reporting is exactly the same. So these two techniques more than double battery life. Once you are down below 10 microamps, you can truly start to think about 10-year battery life on a small battery. You can make these changes and measure them on a real network by using API Explorer. Here's the command to turn off advertising. Be careful, because when advertising is off, no new motes can join. If you want a new mote to join, or if a mote gets lost, your host application should turn advertising back on. Here's the command where I turn the downstream frame mode from fast to normal. The result is that when in this mode, the speed of downstream communication slows down. If you want to speed things back up, you can turn that downstream bandwidth back on by returning the frame mode to fast. It takes a few minutes to switch back and forth, so this is not something your host application can do frequently. What if your sensors include a mix of hardware? What if some of the motes are line powered and the rest are battery powered? There's another very simple configuration option that allows you to tell the network about this. If you know there will be enough line-powered devices to build a good mesh network, then you can turn off routing at all the battery-powered motes. What this means is that when the mote joins, it will inform the network that it cannot afford to be a parent in the mesh. The manager will make sure those motes never advertise and will never route data from other motes. They will always be leaf nodes. This guarantees that those motes will have the lowest possible power consumption and that all these non-routing motes will have similar current consumption. I can make this configuration setting on a mote through API Explorer. I use the set parameter command to set routing mode to true. You can watch these motes join and see that they are never parents in the mesh. If I turn off routing on half of my 20-mote network, the average power consumption of the routers stays about the same, but all the battery-powered leaf nodes drop down to about 9 microamps. This might not seem essential, but now you can see that you can leave advertising on all the time and it never impacts the leaf nodes. The last configuration setting we'll discuss is backbone mode. This is the configuration setting you use if all the routing motes are line-powered, and if you want data latency to be fast, like for alarm messages. We need to make two changes. First, we need to set the routing motes to the max value power source. Second, we have to set up the backbone at the manager. This network mode tells the manager to lay in extra bandwidth that all motes will share and allows data to be sent at lower network latency. Returning to our previous example, the data from these 2-hop leaf nodes will take about 1.5 seconds on average for delivery. But if you run the same network with the backbone on, with size equal to 1 slot, there will be a significant reduction in data latency. Now the data reports from these leaf nodes takes 50 milliseconds on average to deliver. But leaf node power consumption remains at 9 microamps, and the routers now consume over 900 microamps. Such a configuration allows a customer application to take advantage of powered nodes to deliver very low latency and extremely long battery life for the leaf node sensors. To use the backbone in my network, I need to first set every one of the routing motes to the maximum power setting. This tells the manager that the mote should be considered line powered. I use the manager CLI to set the backbone size to 1 and the backbone mode to 1. In order for any backbone change to take effect, I need to restart the network and have it reform with another CLI command. You cannot turn the backbone on and off while the network is running. When the motes all rejoin, I can use Stargazer to confirm that the average latency is reduced. We've now reviewed several ways to interact with your SmartMesh IP network to configure it for optimum performance. SmartMesh IP networks contain simple interfaces to allow users to configure networks to a wide array of performance targets. This configurability allows you to use SmartMesh IP as a wireless network platform, suitable for multiple end-user applications. With the same motes and managers, you can build highly unique networks with just a few simple configuration settings. Tools to assist you are provided by Linear Technology at no cost. Please visit linear.com for more information. Thank you for watching.